We're told that one pipe can fill a tank to half capacity in 3 hours, and a second pipe can fill the same tank to 2/3 capacity in 6 hours, and we're looking for how long it would take them to fill the whole tank. Fill the tank to one capacity, we can say, if the two pipes are working together. We need that time. Well, in the last couple videos, we looked at 3 tools we can use for combined work questions such as this. So let's think about which one or which ones would be most helpful here. Well, this last one's not going to be too helpful. That's the formula we use for a changing number of identical machines or workers working at the exact same rate. That's not the case here. Our pipes are working at different rates. And this middle formula, well, all the variables in this middle formula represent time. They represent time to do the same job, the same amount of work. So that doesn't apply directly either, since these pipes, well, the information that we have is for different amounts of work. There certainly would be a way to use this formula if we played with our numbers a little bit until we had them doing the same amount of work. And I think actually we'll do that in the next video. We'll see how to use this time formula for this question. But if the numbers don't look friendly for that, or if we're not quite sure how to do that, we can always go to our first option here, our sort of principal option. Principal in the sense that it's I guess all these other formulas derive from this same idea. And this option states that, this formula states that we can get the combined rate of some number of workers by adding the individual rates. So let's see if we can make some progress with that method here. We want to find, we know that we can add the individual rate, so we can add the rate of pipe 1 to the rate of pipe 2, and that'll give us the combined rate, the rate together. So what is the rate of pipe 1? Well, if we're not quite sure, we can always go and look at our work rate time mnemonic over here, which states that the rate is W over T. The rate is work per time. And we have that information. Pipe 1 does half capacity. That's the amount of work pipe 1 does in 3 hours. So pipe 1's rate is a work of half capacity over a time of 3 hours. And similarly, pipe 2's rate is 2/3 of capacity per 6 hours. And that is going to equal our combined rate. And let's see if we can write this in a different way as well. Well, we're looking for how long it'll take to do how much work, to do one capacity. So we're looking for how long it'll take to do one capacity, and that is the time that we're looking for, how long it'll take to do one capacity. So we just sort of wrote the rate in a different way here. But it's a nice way to write it because now this variable down here, that represents what we want. That T represents the time to fill one tank to capacity if they're working together. So we're in a good situation. We've got a single equation with a single variable. All we really need to do is isolate that variable and we'll have our answer, which means we're going to have to go back to our fraction rules here to simplify this. Well, here I'm dividing a half by a third. So what's the rule for dividing fractions? Actually, I'm just going to write this 3 as a fraction so we can visualize the rule more easily. I'll write, God, kind of ugly. I'll write 3 over 1 rather than just 3, and I'll write 6 over 1 rather than just 6. So what's the rule for dividing fractions? Well, to divide fractions, I just multiply the numerator by not the denominator in its current form, but the reciprocal of the denominator, the flip of the denominator. So here I have 1/2 times 1 over 3, and here for the second term I have 2/3 times 1 over 6, and that is going to equal 1 over t. Multiplying fractions, we just multiply across the top, multiply across the bottom. So our first term becomes 1 times 1 is 1, 2 times 3 is 6, plus our second term becomes 2 times 1 is 2, and 3 times 6 is 18. all equals 1 over t. And to add fractions, we need a common denominator. So here I've got a 6, here I've got an 18, but I can turn this 6 into an 18 if I just multiply top and bottom of this fraction by 3. And that leads me to, for the first term, I have 3 over 18. For the second term, I have 2 over 18, and we can add these together. 3 plus 2 is 5, and we keep the same denominator. 5 over 18 equals 1 over t. So we're almost there. We don't want 1 over t, we want just t. But we can now just flip both sides of this equation. If both sides of an equation are just a single fraction, you can take the reciprocal of both sides. So if I flip both sides of this, take the reciprocal of both sides, I get 18 over 5 equals t, which is what we're looking for, right? We said that t is how long it would take to fill one tank. So we've got our answer, but our answer choices are in decimals, not fractions. So let's just go up here to convert this to a decimal. 18 over 5. Well, 5 goes into 15 3 times. So 5 goes into 18 3 times, and there's 3 left over between 15 and 18. So 3 left over leads us to 3/5. And as a decimal, that is 3.6, which leads us to answer choice B. So one reliable way to attack questions like this, you just add the individual rates to get the together rate. I mentioned early on that we could also use this second formula, and I do want to do that in the next video. I encourage you to try to apply this formula first to this question, and then we'll go over it together in the next video. I'll see you there.